In today's lesson, we're going to have a look at drawing and interpreting scatter graphs. Scatter graphs are used to show whether there's a relationship between two sets of data. There are 5 things that we're going to look at in today's lesson. Number 1 is describing the type and strength of correlation. Number 2 is drawing a line of best fit. 3 is describing the relationship between the sets of data. 4 is plotting points onto a scatter graph. And 5 is using the line of best fit to make estimates. There are 3 different types of correlation you need to be able to recognise on a scatter graph. You've got positive, negative and no correlation. They are being displayed on the screen right now. If a scatter graph has positive correlation, it means as one quantity increases, so does the other. In our example, you can see that as the shoe size increases, so does the height of the person. All of the points are in a trend which go from the bottom left of the scatter graph to the top right. If a scatter graph has negative correlation, it means as one quantity increases, the other decreases. So in our example, you can see that as soup sales increase, the temperature decreases. In this situation, all of the points are in a trend which go from the top left down to the bottom right of your scatter graph. Lastly, if a scatter graph has no correlation, it means that both quantities vary with no clear relationship. As you can see in our example, there's no pattern between the annual income and the shoe size. In this situation, there's no trend and the points are simply scattered across the whole of the graph. So the first thing that I'd like you to do is pause the video and have a look at the 6 examples of scatter graphs that you see on the screen. I'd like you to write down whether each one has either positive, negative or no correlation. When you're ready for the answers, simply unpause the video. Here are your answers. The first one was positive, number 2 was negative, 3 had no correlation, 4 was negative, 5 was positive and 6 was negative. Sometimes a line of best fit can be drawn. You should draw a line of best fit to characterise both positive and negative correlations. You shouldn't draw a line of best fit if there's no correlation. Looking at our examples again, the line of best fit for positive correlation would look a little bit like this, and for negative correlation would look like this. As the name suggests, you should try and draw a line which best fits the points that are given on the scatter graph. There is no easy way of calculating what this line should be, so therefore for now you should simply use your best judgment as to where the line should go. Some good guidance would be that you're trying to get an equal number of points above and below the line, and you're also trying to minimise the distance from the line to each of the points. You can also use the line of best fit to determine the strength of correlation. The strength of a correlation is dependent on the spread of points around the line of best fit. In our top set of examples, we've got strong positive, moderate positive and weak positive. You can see for strong positive that the points are all very close to the line of best fit, whereas for weak positive they are still going in a positive direction but they're more spread out. Likewise, in the bottom set of examples, they all have negative correlation, but we've got strong negative where the points are all very close to the line, moderate negative in the middle, and weak negative where it's still going in a negative direction, but the points are more spread out. Something to note is that you only need to state this if it asks for the strength of the correlation. Otherwise, you can simply say positive or negative. Another important observation is that most of the time in tests they'll ask you to describe it as either strong or weak, and moderate correlation is very rarely used. Another thing that you might be asked to do is describe the relationship between 2 sets of data. This shouldn't be confused with describing the correlation. When you're asked to describe the correlation, you use the words positive, negative or no correlation. When you're asked to describe the relationship, you need to summarise what the data shows in the scatter graph. In my first example, we could say taller people tend to have a bigger shoe size. That's because it has a positive relationship, and therefore as shoe size increases, so does the person's height. In the second example, we could say soup sales are higher when the temperature is low. That's because as soup sales increase, the temperature decreases. In the last example, we could say there is no relationship between income and shoe size. That's because there's no correlation. So what I'd like you to do is pause the video again and have a go at describing the relationship of each of these scatter graphs. We've already described the correlation, so you can use that to help you when forming your sentences. When you're done, simply unpause the video for the answers. So for the first scatter graph, we could say people with higher math scores tend to get higher physics scores. In the second scatter graph, we could say as the engine size of cars increase, they use more petrol, i.e. less miles to the gallon. And in the third example, we can say there's no relationship between Key Stage 3 results and the height of a student. In our fourth scatter graph, we can say as the outside air temperature increases, heating bills will be lower. For our fifth example, people tend to buy more sun cream when the weather is sunnier. And lastly, for question 6, the older the car, the less its value. The important thing to remember is that you're only commenting on what's shown in the scatter graph. Obviously, people might argue that there's some really vintage cars out there that are really old but actually have quite a lot of value, and that wouldn't be represented by the scatter graph that we're given. So the final thing we're going to look at is putting all of this together with plotting a scatter graph and then interpreting it. In our example, the data shows the shoe size and mass in kilograms of 10 people. You can see that information in the table. Part A asks us to plot these points onto the scatter graph. So, looking at my data points, I can see the first person has a shoe size of 5 and a mass of 65 kilograms. So I need to go across the 5 on the shoe size axis and up to 65 and put a cross. I need to repeat that for the other 9 bits of data. So the second person has a shoe size of 12 and a mass of 95. That'd be just there. We've then got 7 and 70, 10 and 90, 10 and 80, 9 and 80, 8 and 75, 11 and 90, 6 and 75, and lastly 8 and 80. So that is all of the points plotted onto our scatter graph. I think it's really useful to tick off each point as you go along so you know you haven't missed any out. Part B asked me to draw a line of best fit. I think that it would look something like this. Part C asked me to describe the correlation shown. Because as shoe size is increasing, so is the mass. That means it has a positive correlation. Notice how it hasn't asked for the strength, so I don't need to say whether it's strong, moderate or weak, just whether it's positive, negative or no correlation. Part D asked me to describe the relationship, so I could say something like people with bigger shoe sizes tend to weigh more. That is what my data is showing. Lastly, Part E asks us to use our line of best fit to estimate certain answers. So, if I'm asked to find the mass of a person with a shoe size of 10.5, I would first find 10.5 on the shoe size axis and draw a line that goes up to my line of best fit and then across and find out what mass we would expect them to have. So I can see the mass of a person with shoe size 10.5 would be roughly 87 kilograms. It's really important that you get in the habit of drawing this line on, because if you're asked to do this in a test, this is considered part of your working out. Likewise, if we're asked to find the shoe size of a person with mass 69 kilograms, we go to the mass axis to 69 kilograms, draw a line across to the line of best fit and down, and we can see that they would have a shoe size of 6. So your task for today is to log into MyMass and complete the task on Scattergraphs that's been set for you. Remember that the first login is always the school login, that's Uppingham and Acute, and then you'll need to log into your portal. If you forgot these details, they're attached to Show My Homework in the Resources to Help You section. To show you've understood everything on Scattergraphs, you should aim to get at least 70% or higher on this task. You can repeat it as many times as you like to get this score, and if you need to, you can find it again in the Results tab if it's disappeared from your homework list. If you are struggling to complete some of the work from today's lesson, then please do not hesitate to get in touch via comment on Show My Homework. I'll try to make myself as available as possible and get a reply to you as quickly as I can. If the issue requires a little bit more input from myself, I might ask to arrange a time to meet on Teams where I can give you some personalised help with that specific problem.